Monday will be review this homework, review the chapter, and test on Tuesday. Use your weekend accordingly. Some of you struggled last quiz. Your struggles will not magically go away unless you do something about it. You have to recognize areas of struggle and work in those areas, okay? By the way, basketball ends this weekend, so I'll be around Monday after school. Feel free to come by and get some help. Be glad to help you out and answer any questions and stuff and show you stuff that you might need help in. Okay, let's roll with 8.6. I just hit my keyboard. That was bad. All right, exponential growth and decay. If you invest your money, you want it to grow. If you have an infection, you want the bacteria to decay. All right? You ever get an antibiotic and they say make sure you take it all the way until the bottle's done? You know why? Because as you're taking it, the bacteria level is decaying, going down, and you'll start to feel better when you still have bacteria in you. And if you don't continue to take the medication, instead of it continuing to go down to 0, it'll start going back up again. And usually even worse because you're starting at a higher amount. Anyhow, growth and decay. All right, we're going to learn some things to understand here with growth or decay. All right, growth. As X, the input, increases, then Y, the output, increases. I think I mentioned this to you guys yesterday, but I have to be careful. I'm doing similar things in Algebra 2 and Algebra 1, and I can get the two classes confused. As you go left to right for the X's, all right, here's the X on the left. As you head to the right, what's happening to our output? So watch. I'm going to take a value right here. Input that value, I output that value, yes? As I move to the right and I input this value, now I'm outputting a higher value, right? As I continue to move to the right, I'm outputting an even higher value. That's an exponential growth. It goes up to the right, exponential growth. Again, if this were money, you'd want it to grow. Other situations, you might want it to decay. Population right now in the world, it's a growth. China, trying to stop that, has the one-child policy, right? And in a means, but really our population is growing at phenomenal amounts, and that's a whole other issue. Okay, so that's growth. Oh, examples, population, bacteria, investments. Population, bacteria, there are others. Investments. Now to determine decay, we're going to do the exact same thing. We're going to increase the input and see what happens to the output. So again, our input, we're moving left to right and seeing what happens to the output. Let's take an input right here. The output is up here, yes? As I move to the right, what happens to my output? It's decreasing. That's a decay. And you can see that curve goes down to the right. If you invest your money, you don't want it to be a decay. Right now in Europe, in China, in Japan, the banks have negative interest rates. Did I mention that to you guys yesterday? Okay. So again, it's a decay. That's not good. Not good for world finances. All right, so as X, the input increases, Y, the output decreases. You always increase the input to see what happens to the output. Output goes up, growth. Output goes down, decay. Hey, hey. All right, some patterns. We've gotten some patterns before. We have some patterns now. In the growth and decay aspect, we have the initial amount. The initial amount. That's the blue A in that one and the blue A in that form. I'm showing you two different forms. Okay? They're similar, but a little bit different. These are the multipliers of the base, yes? Right? They're not part of the base, right? And by the way, when I say base, everybody knows what I'm talking about, right? Because from pre-algebra, I taught you exponent and base, right? So the A is the multiplier of the base. It's the initial amount. The 1 plus R, well, let's do the R. The R is called the growth rate. The R is the growth rate. But the whole base is called the growth factor. The whole base is the growth factor. It's in the left form, the 1 plus R. And in the right form, it's the B, right? I'm color-coded here to help you out. In the left, the growth factor is the 1 plus R, the parentheses total, right, that the exponent applies to. And on the right, it's the B, the base of the exponent. In this instance, the exponent t is time. But t is not always time. It depends on the situation. In this situation, t could be time. We're not sure. It's simply the independent variable. You don't even need to write that in, but you can if you want. And f of t or y is the output, right? The y value for any given input. Okay, so let's see if we can make some sense of things. In the first scenario, number 1 underneath the base, if when you add up 1 plus r and your value is less than 1, what happens when you take a number less than 1 and put it to a power? You're getting smaller. For example, what's 1/2 squared? 1/4. See, we're now smaller than even 1/2. What's 1/2 cubed? 1/8. We're getting even littler yet. Same with the whole B here. Again, B and 1 plus R, same concept, two different forms. So whenever 1 plus R is less than 1 or B is less than 1, it's got to be an exponential decay. Because if you can't think, you can certainly see the color, all right? It's decay. Again, you're getting smaller. Take the exponent 3. Again, use the 1/2 example. That's between 0 and 1, less than 1. And 1/2 to the first power is a half. But 1/2 squared is 1/4. We're getting smaller. But if 1 plus R is greater than 1, or B is greater than 1, it's got to be an exponential growth. That should be green. And we're going to go up and away. Exponential growth. Right now, the banks have a negative interest rate. That means, unfortunately, it's an exponential decay. You put your money in the bank and you get less. Put your money in the bank and a month later you have less money than you put in. It's an exponential decay. That's what that means, negative interest rate. All right. Real life, 2016. Okay, so there are formulas again on the next page for you because I want you to be able to see them, okay? So again, the base is called the growth factor, or GF for short, 1 plus R or the B, right? All right. And again, decay and growth. All right, so that's all there again as we try to then look at an actual function and figure out what's going on. And this is what we want you to learn from this lesson. I want you to be able to look at a function or write a function and know what things mean. So in this scenario, the initial amount is 2,000 because I'm not colorblind, right? 2,000. That could be population, it could be money, who knows? Bacteria, whatever. What is the growth factor? What is the growth factor? Somebody raise your hand and tell me the growth factor. Kirsten. Huh? So the growth factor is? 3.5, thank you. Yes, last time I checked, 1 plus 2.5 is 3.5. Okay, that's the base, and you get an idea how quickly that's going to go up. Just used a 3. 3 squared is 9, but 3 cubed is already up to 27, right? 3 to the 4th is up to 81. This is even going to go up more because it's 3.5. That's a pretty aggressive growth rate. Is this a decay or a growth? This is a growth. 3.5 is bigger than 1. If 3.5 is bigger than 1, it's a growth. If the growth factor is bigger than 1, it's a growth. If the growth factor is less than 1, it's a decay. Okay, so that was all color-coded, nice for you. Second example. No color. Oh no. Lions and tigers and bears, oh my. Class, what's the initial amount? 32,000. All right. See your math skills. The growth factor is 0.25, right? Is this a decay or a growth? Decay. The base is less than 1. Growth factor 2.5 is less than 1. This thing is decaying. Away we go into decay. It's our economy. All right, third one. Initial amount? 750. Growth factor? 1.5, right? Other form. Decay or growth? Growth. Not bad if you remember what things are, right? At least these examples. How about the last one? Go ahead and fill it out. You fill it out yourself. Give the initial amount. Give the growth factor. Say if it's decay or growth. And hopefully you said 5, 7 in growth. Questions on that? We're reading the function because we know what stuff represents. We know what stuff, I went backwards. Okay. One reminder here, R is the growth rates. R is the growth rates. 1 plus R is the growth factor, right? Just R is rate, so hopefully you can remember that. The whole thing, the 1 plus the rate, is the growth factor. All right, we'll need that in a moment. Because now in this one, we know the initial amount is $2,000, right? The growth rate is 2.5. What is the percent growth rate? Turn 2.5 into a percent. 2.5 is how much percent? 250%. And that is the growth rate in a percent. Okay? So now let's see if we can interpret this in the different forms. So the second example, we're in this form. Now you got to do some thinking. Because remember, we want R, right, mateys? And therefore, you say R is. All right, wait, let's do it on 3. R is 1, 2, 3. 4.2, right? Because you have to think, I need 1 plus R. And if the value is 5.2, it must have been 1 plus 4.2 to give an R. Because R is when there's a 1 plus it. R is the growth rate. 1 plus the growth rate. Didn't we say 2.5 down here? Well, they didn't show you the 1 plus. Oh my. You had to figure it out. 5.2 is 1 plus 4.2. Growth rate, 4.2. You had to put it in the right form. They didn't give it to you in the right form. They gave it to you in this form. You have to understand, if I want to say the growth rate, I got to make the parentheses 1 plus to add up to whatever the base is. Okay. If you can't do that, you're going to have to look at that for a little bit and make it make sense to you. Because I don't know how any other way to explain that, because it's like way too simple in my mind. Okay? If the whole base is 5.2, it had to have been a 1 plus 4.2. How else did it end up 5.2? The 1 plus is always there, and then you got to add up to it. All right, well, we'll see if that really sinks in a moment. All right, C is easy. The growth rate is negative 0.7, right? The growth rate is negative 0.7. Oh, we didn't do the percent on B, did we? 4.2 in percent form is 420%. It was easy. Now, here's a little bit tricky. Well, we'll go easy. We'll do negative percent. A negative 0.7 is negative what percent? Negative 70%. Oh, cramp, sorry. It's not good when you get a cramp in your side. All right. Okay, so negative 70%. Pretty simplistic. D, growth rate. Pretty easy, right? 0.3. Percent, 30%. And I should have given you one more, so let me give you one more. Let's do one more here. Let's do an E. Let's do Y equals 700 parentheses 0.65 to the X. Y equals 700 times parentheses 0.6 to the X. All right, I need the growth rate, and then I need the percent growth rate. What is the growth rate? What is the percent growth rate? Somebody give me the growth rate. Adam?
Negative 0.35.
Awesome. Adam's got it down. He's got it figured out. Negative 0.35 has to be that growth rate. Again, if you don't know how you got there, it's got to be 1 plus what value to give you a 0.65. Well, the only thing is 1 plus negative 0.35 equals 0.65. And therefore, then, the percent is negative 35%. Got it? Good. Questions there before I go on? See, when they only give it to you in the total base form where everything's added up, you have to unadd the 1 plus to read the growth rates. Only the R is the growth rate. The 1 plus R is the growth factor, but we didn't ask you the growth factor. We asked you just the growth rate. And Daydreamer, you're the very one I'm trying to do this for. All right, so if you're not going to listen, I can't help you. All right, number 4. Write the function in the form of f of t equals ab to the t. So we're going to put it in that form and state if it's a growth or decay. All right, so they tell you an initial amount of 37 and a growth rate, they gave it in fraction form, 4/3. And they said it was the growth rate. Okay? They want it in this form. Go ahead and see if you can write that. I'm going to pause the video. My question is really going to come into play, did you get the base correct? Because hopefully everybody put 37 in for the A, right? And T is just T. So on 3, tell me what you put in for the base. Here we go. 1, 2, 3. I love it. How about 7/3? How about 7/3? Isn't the growth rate the R? Isn't growth rate R? Isn't growth rate R? Yes? Don't look cross-eyed. Isn't growth rate R? Yes or no? Yes or no? Yes. So if they gave you R, the base has to be 1 plus R, yes? Well, it's 1 plus 4/3. All right? And that's what you had to do. You had to do 1 plus 4/3. Common denominator, add the fractions. 3/3 plus 4/3, 7/3. R is 7/3. Anybody get it? A couple of you? All right. What a shame. You just got to keep track. Growth rate is the R. And the base is always 1 plus R, you pirates. Come on. I'm going to make you walk the plank. That's not hard. 1 plus isn't hard, folks. Austin, how old are you? You're 1 plus 14. Oh, my. I know it's hard to understand, but, I mean, it's a tough concept. Okay, just you got to remember the 1 plus R, and you have to remember when they're saying, now the last question you would struggle with. Well, maybe not. The initial amount is 2,100. That's easy. That's the A, right? But again, they say growth rates. Growth rates. So they give it to you in a percent this time. So see if you can finish this one. B is a decay. All right, on 3, tell me your base. That's all I want to know, what you put in for the B. All right? Here we go. On 3, 1, 2, 3. 0.8, right? How many had 0.8? There you go. Because again, it's got to be 1 plus the growth rate, which is a negative 0.2. Therefore, 0.8. Ethan. Huh? That's fine. If you would have done that, you would have done what, 4/5? Same thing. And this one, hey, Ethan, because that one's already in decimal, just leave it decimal. The first one was already in fraction, so you continue fraction, right? Any other questions? Anybody else? All right. Hey, last assignment of the chapter. Take care of issues this weekend. Recognize